Hello guys, welcome to my channel. In this video, we are going to study the chemistry subject in which we are going to study about ionic product of water. I have my book which is chemistry and the question bank here and the solution here um, with my red pen and black pen and with my amala. Okay, I'm opening my book. I can get syllabus also in this book. My topic is ionic equilibrium. In the previous video, we studied the Ostwald-Giles law. I'll be reading after that topic, which is the ionic product of water, KW. Ionization of water. Though water is regarded as a bad conductor, yet the purest water has a very low conductivity, as it ionizes to very small extent and is endothermic and reversible in nature, according to the Frederick Cold. Cold. This spelling is too hard for me. Frederick QHLRUSCH report. H2O H plus OH minus. It can also be written as H2O plus H2O H3O plus OH minus. Thus, a reaction in which two molecules of water interact to give hydrogen and hydrogen ion. It's called self-ionization of our water. Since it is a reversible process, the law of mass action can be applied to the equilibrium. K is equals to S plus OH minus upon H2O. All have the molar concentration of S plus, molar concentration of OH minus, and molar concentration of H2O, where K is the ionization constant or dissociation constant of water. The concentration of undissociated H2O, that means H2O, is practically equal to its initial molar concentration. It is because water dissociates feebly. Approximately 1 mole of H2O ionizes out of 550 million molecules. Therefore, H2 H plus molar concentration of H plus into molar concentration of OH minus is equals to K molar concentration of H2O, or H plus. Molar concentration of H plus and molar concentration of OH minus is equals to Kw. Kw is a constant at a given temperature and is known as ionic product of water, which increases with increase in temperature. Okay. It is defined as the product of molar concentration of H plus ion and OH minus ion at particular temperature. Its value at 25 degrees Celsius is found to be 1.0080 in 10 to the power minus 14. However, for simplicity, we can write Kw is equals to 1 into 10 to the power minus 15 mole per liter square. More mole per liter whole square. 1 liter of water is equals to 1000 cc cubic centimeter is equals to 1000 gram. Okay. Density of pure water is equals to 1 gram per cc. Molar mass is equals to 18 gram per molecule. Now substituting both values, both the values are in the above equation we get. Okay. Oh my god, I forgot to read out the previous topic, which was, I'll read now. Sorry for that. S2 molar concentration of S2 is equals to number of moles of water per liter. Yes, molar concentration of water is equal to number of moles of water per liter, which is 1000 upon 18 is equals to 55.54 mole per liter. 55.54 mole per liter. 1 liter of water is equals to 1000 cc. 1000 is equal to 1000 gram. Density of pure water is equals to 1 gram per cc. Molar mass is equals to 18 gram per mole. Now substituting both the values in the above equation, we get k is equals to molar concentration of H plus into molar concentration of OH minus upon molar concentration of H2 is equals to Kw, which is the ionic product of water and the product of molar concentration of H plus and molar concentration of OH minus at constant temperature. And the upon molar concentration of H2O is equals to 1 into 10 to the power minus 14 upon 55.4 is equals to 1.8 into 10 to the power minus 16. This is the value of K. Okay. Thus the value of ionization constant of water is equals to 1 by 55.4 times that of ionic product of water. Ionic product Kw at 25 degrees Celsius. It should be noted that the ionic constant for water is 1 by 55.24. Am I right? I mean 54. Uh, 1 by 55.54 times the ionic ionic constant is ionic constant of water is 1 point ionic constant of water is 1 of 155.54 times the okay ionic product of water at 25 degrees Celsius. For pure water, H plus is equals to OH minus. Okay, I mean the molar concentration of H plus is equals to the molar concentration of OH minus. From equation I, which is the Kw is equals to H plus OH minus. Molar concentration of H plus into molar concentration of H minus is equals to K. We can write as molar concentration of H plus into molar concentration of H plus is equals to Kw. H plus is equals to H plus molar concentration of H plus is equals to root under Kw, because okay H plus mm, molar concentration of H plus is equals to root under 10 to the power minus 14. Okay, the 10 to the power minus 7 mole per liter. Again H plus is equals to OH minus. From equation I, molar concentration of OH minus into molar concentration of OH minus is equals to Kw. OH minus is the molar concentration of OH minus is equals to root under Kw. OH minus is equals to molar concentration of OH minus is equals to root under 10 to the power minus 14 is equals to 10 to the power minus 7 mole per liter. A solution in which H plus ion concentration is equal to OH minus ion concentration is called a neutral solution. Okay. This is the discussion of ionic product of water. Mm, The main thing is the molar concentration of H2 in the derivation of the formula of ionic product of water is supposed to be 1. I will read that section again. Where K is called the ionization constant or dissociation constant of water, the concentration of undissociated H2, that means molar concentration of H2, is practically equal to its initial molar concentration. It is because water dissociates feebly approximately 1 molecule of ion H2 ionized out of 550 million molecule. H plus molar concentration of H plus into molar concentration of H minus is to K molar concentration of H2. Let's discuss the effect of temperature on the ionic product Kw and dissociation constant. Mm. The ionic product of water increases with an increase in temperature due to endothermic nature of ionization. The ionic product of water increases with increase in temperature due to endothermic nature of ionization. Since the increase in temperature dissociates more than now dissociates more water molecules into H plus and OH minus ion. In the another world, the degree of dissociation increases with an increase in temperature, and ionic product also increases. The calculated value of Kw at different temperatures are given below. At 0 degrees Celsius, it is at 0 degrees Celsius, Kw is equals to 1. And this is not important for us. It's a rise in temperature, the ionic product of water as well as dissociation constant. No. The rise in temperature increases the ionic product of water and ionization constant. At body temperature, Kw is equals to 2.5 into 10 bar minus 14 mole per liter whole square. Okay. Here's a question. How do ionic product of water Kw vary with temperature? How will temperature affect the pH value of water? Ionic product of water increases with an increase in temperature because the ionization process is endothermic. That means H2O, H plus OH minus heat, reversible and endothermic. Endothermic means you have to give heat for the equilibrium. Thus, increasing temperature shifts the equilibrium in forward direction. At high temperature greater than 25 degrees Celsius, H plus is equals to OH minus ion. In the concentration of H plus and concentration of H plus is equals to concentration of OH minus is greater than 10 to the power minus 7 mole per liter. The Kw is equals to H plus concentration of H plus into concentration of OH minus, which is Kw is greater than 10 to the power minus 7 into 10 to the power minus 7. Kw is greater than 10 to the power minus 14 mole square liter per liter square. The thus the value of Kw will increase with the increase in temperature. On the other hand, at temperature T is greater than 25 degrees Celsius, the S plus is greater than molar concentration of S plus is greater than 10 to the power minus 7 mole liter in birds. I mean mole per liter. So the pH of water will be less than 7. Condition for neutrality of Q-2 is molar concentration of H plus is equals to molar concentration of OH minus, but not pH is equals to 7 at all temperature. Of effect of addition of an acid or base in water. As you know, in pure water, the concentration of H plus ion and hydrogen ion and hydroxyl ion is equal. If we add any acid in water, the concentration of H plus ion increases above 10 to the power minus 10 mole per liter. That means separation of ionization of water. At the same time, concentration of OH minus ion decreases before 10 to the power minus 7 mole per liter to make a ionic product of water constant at a particular temperature. Similarly, when a base is added to water, then OH minus concentration increases while that of hydrogen ion S plus ion decreases. When any base is added to the water, decreases. No. Thus, an addition of either acid or base in water at a particular temperature, the ionic product remains constant. Hence, hence if H plus is equals to OH minus molar concentration of H plus is equals to molar concentration of OH minus, the solution is neutral. If the molar concentration of H plus is greater than the molar concentration of OH minus, it is acidic. If the molar concentration of H plus is less than molar concentration of OH minus, the solution is basic or alkaline. Relation between pK and Kw. pKw is equals to minus log 10 Kw is equals to minus log 10 1 into the power minus 14. pKw is equals to 14 at 25 degrees Celsius. What is pKw? Okay. It has, I don't know what is it. pK of an acid and pKb in an acid. I think pH, POH. We'll discuss it in later videos. Let's learn more about this ionic product of water through our question bank. I have my red pen. Mm. The value of ionic product of water is 393 Kelvin. Okay. Let's simplify this. Okay. 393. 393 minus 273. 0, 2, 1. 120. Okay. 120 degrees Celsius. 120 degrees Celsius. Yes, 120, which is greater than 25 degrees Celsius. Yeah, that means the what ionic product of water is the should be greater than the should be greater than yes greater than 1 in 10 power minus 14 b 8b 8b, yes it is b. Okay, I will write it in my book. Here I can write value of ionic product of water at 393 Kelvin is greater than what? Is is dot. I won't write the answers. Okay, maybe there will also be MCQs more or not. Oh, you are not any problems. MCQs. Let's go to the short answer questions. There are no any questions relating to it. I'm not finding that which I need. Yes, here is a question which was asked in 2079. Okay, first of all I will write this question. This is a full question which was asked in 2079. Define ionic product of water. Ionic product of water. Deduce the relation Kw is equal to S plus OH minus. Deduce. I'll shorten it. I'll shorten yes. Deduce the relation. I didn't make it short. S plus OH minus. Calculate the OH minus concentration of 0.01 mHCl at 25 degrees Celsius. Can I solve it or not? Let's try to solve. What is the question? Calculate the OH minus concentration of 0.01 mHCl at 25 degrees Celsius. The SCl concentration of SCl is given, which is 0.01. 0.01. Okay, 0.01. Um, mm, mm, that means the concentration of S plus and OS minus will also be 0.01, isn't it? The OH minus, no, KW. Yeah, I think I have KW is equals to 1.1 into bar minus 14, 1 into bar minus 15, 14 what mole per liter whole square. We have OS minus is equals to what? Yeah, we know at 25 degrees Celsius, S plus is equals to OS minus equals to OS minus, isn't it? Yeah, is it? And and what? H plus is equals to what? OS minus is equals to under root KW is equals to under root 1 into power minus 17 is equals to minus 10 to the power minus 7. Is the concentration. How can I find now? Power minus 7 mole per liter. Okay. What was the question? Calculate the OH minus concentration of 0.01 mole HCl at 25 degrees Celsius. No idea what to do next. But HCl analysis is S plus Cl minus ion. H plus Cl minus ion. Okay. Concentration of H plus Cl is 0.0. What is 0.01? That of HCl will be equal to the H plus concentration of H plus 0.1. Then Cl minus will be also 0.01. 0.01. I can solve. It takes time, but I will make the numerical video on the next upcoming Saturday. I will try to solve it there. Let's do some what understanding, no, remembering questions which will ask in the examination. Okay. Mm. Define ionic product of water. Okay. Instead, it is defined as the product of molar concentration of S plus ions and OH minus ion at a particular temperature. Mm. Deduce the relation Kw is equals to S plus and OH minus. Product of S plus and OH minus. Okay. This is simple. We have to consider a reaction as to gives H plus H2 S minus. Okay. For simplicity, you can write S2 S plus Y minus. And since it is a reversible process, the law of action can be applied to the equilibrium K is equals to S plus Y minus and S2. Where the key is called the ionization constant and dissociation constant of water. The concentration of undissociated S2, that means S2, is practically equal to its initial molar concentration. It is because water dissociates feebly, approximately 1 molecule of S2 ionizes out of 550 million molecules. Therefore, S plus molar concentration of S plus into molar concentration of OS minus is equals to K into S into molar concentration of S2 or S plus into OS minus is equals to KW. KW is a constant at a given temperature and known as the ionic product of water, which increases with increasing temperature. Maybe I can solve it now, but I have found something. I'll use the above equation H plus OH minus is equals to K H2. But how can I solve it now? No, I can solve. Maybe I can use my solution to get the answer. What is the question number? Question number 10. Question number 10, 10, 10, 10, 10, 10, 10. 2079. There is no question number system here. Yes, here the question. S2 plus H2, S3 plus OS minus. Okay, by applying the law of mass action, key key equilibrium constant. Key equilibrium is equal to concentration of water is secondary constant. K into S2 whole square. KW is equal to S3O plus OH minus. There is an expression. And simply it is written as KW is equal to S plus OH minus 7 for 0.01. Okay. For 0.0 mSL, as concentration of S plus is equal to 0.01. We know that the concentration of S plus is equal to. It was so simple now. So simple, bro. Concentration of S minus is equal to concentration of K upon concentration of S plus L bar minus 14 upon 0.01 is equal to 10 bar minus 2 bar m. Air concentration of H minus ion is equal to 0.01 m SL 825 degrees L bar minus 12 That was simple. Okay, let's go to another. What is the effect of temperature on ionic product of water? Hmm. I read it again. The ionic product of water increases with an increase in temperature due to the endothermic nature of ionization. Since the increase in temperature dissociates more water molecules into S plus and OS minus, in other words, the degree of ionic dissociation increases with increase in temperature, hence ionic product also increases. The calculation of Kw at different temperatures are given below. Mm, okay. Mm, okay. Let's move to new another topic. I mean the another question. The old course, but then this define ionic product of water. It was also asked in 2073 supplementary exam. No, there aren't. There is no questions relating to it. So I found this number 51 2065. What is the ionic product of water? We also asked in 2065. It was also asked in 2071 and 71 was also asked in 2071 and also asked in 2067 also. 67 also. Okay. This was okay. Let's go to the new topic, which is definition. I'll underline it. And molecular body temperature. And I will also underline the important topic. Let's consider reaction. Is the derivation. Derivation. Okay. Effect of temperature. Effect of temperature. Okay, I'll underline some topics. Distillation consists of acid and base Ka and Kb. Right? Distillation consists of um, strength of acids in terms of Ka. Ka means ionization constant of A. Really? Is K means that? Ionization constant. What is ionization constant? Yes, I. Molar concentration of ionic species to the molar concentration of unionized species. Okay. Study this. The strength of acid or base depends upon their ability to give H plus and OH minus ion respectively. Acids like HCl, HNO3 and H2SO4. Its crystals dissociate completely in an aqueous solution and produce a large number of H plus ion. And they are called strong acids, while acids like Cl3COH, H2CO3, H3PO4, HCl ionize to a small extent in the aqueous solution, and they are called weak acids. Okay. Dissociation of weak acids. The strength of weak acid is compared in terms of ionization constant. Smaller the value of ionization K, what is K? Smaller the value of alpha. The alpha means the degree of ionization, which is the ratio of, in my book it is the ratio of number of molecule ionized upon molecule number of molecule dissolved. And weaker, smaller the value of K, smaller is the value of alpha, and weaker is the acid and vice versa. This relation between strength of acid in ionization, this relation between strength of the acid and ionization constant is explained by applying Ostwald dilution law. Let's consider dissociation of weak monobasic acid. You know what is monobasic? The acids which has its basicity is equals to 1 is called monobasic. Basicity means the number of acids and present in the acid, or number of molecules present in the number of acids and present after dissociation of acid. Ha plus H2O. No, no. Consider dissociation of weak monobasic acid Ha in water. Let the initial concentration of Ha be 3 mole per liter and alpha be its degree of dissociation. Then we can write Ha plus H2 is equals to H3O plus Ai minus. Initial concentration C. Okay, C. H3O plus 0 and A minus also 0. Equilibrium concentration C minus C alpha Ha. The concentration of Ha is equals to C minus C alpha, and H3O plus is equals to C alpha, and A minus is equals to C alpha. And equilibrium concentration of various species are molar concentration of Ha is equals to C minus C alpha mole per liter. C minus C alpha mole per liter. H3O plus is equals to C alpha mole per liter. A minus is equals to C alpha mole per liter. Ha mole per liter. Okay. K equilibrium is equals to H3O plus A minus. Molar concentration of H3O plus molar concentration of A minus upon molar concentration of VHA into molar concentration of H2O. K equilibrium is into K equilibrium into H2 is equals to KH3O plus K minus upon HA, or K. What is K? The new term. K is a new term. Similar, the ionic product of water is Kw. I think the ionic product of acid is Ka. Really? Okay, K is equals to H3O plus A minus upon HA upon. I won't read the molar concentration. It is long form. The concentration of H3O plus is equals to Ca, and A minus also Ca into C square A square or B square upon C minus C alpha. A. A square C upon 1 minus alpha. The degree of ionization of weak acid is very small, so 1 minus alpha is nearly equal to 1. K is equals to alpha square C, or alpha is equals to root under K upon C. Thus, the smaller the value of K, smaller is the degree of ionization, and vice versa. Now, S plus consideration in terms of ionization constant is given by now S plus consideration in terms of ionization constant is given by S plus is equals to C A alpha. I mean C alpha. Consideration of S plus is equals to C alpha. Yes. C is equals to root under consideration of root under K upon C is equal to root under Kc. S plus is directly proportional to root under K, or the same consideration of two different acid solution. The solution of S plus depends upon the ionization constant of the acid. Oh, K means the ionization constant of acid. For same consideration of two different acid solution, the concentration of S plus ion depends upon the ionization constant of the acids. It shows the higher is the value of ionization constant, higher is the strength of the acids, and vice versa. Hence, the relative strength of weak acids can be compared based on their ionization constant value. Relative strength of weak acids can be compared based on their ionization constant value. Let us consider two acids Ha1 and Ha2 and Ka1 and Ka2 with the ionization constant and alpha 1 and alpha b2 with the degree of ionization. Then degree of ionization of acid solution having the same molar concentration is given by A1 is equals to root under K1 upon C and K2 is equals to root under K2 upon C, or A1 by A2 is equals to root under K1 upon K2. The degree of ionization is measured to its ability to keep S plus ion, which in turn is a measure of its strength. Hence, we can write strength of the acid Ha1 upon strength of the acid Ha2 is equal to root under K1 upon K2. Oh my god. How much? Oh my god. Okay. Strength of bases in terms of KB. It is a huge topic and I can't give a proper lesson. I will read you tomorrow. I have to go to my coaching, which will start at 6:30, and I have to do some preparation. Okay, bye. Thank you. Like and share. Subscribe. Bye bye.